Imagine standing on the edge of everything. Now ask yourself, what's past that edge? If the universe has a shape, then what is it? And if it has a shape, does that mean it has a boundary? And if it has a boundary, what lies beyond it? Tonight, we embark on a journey not just across space, but into the very nature of space itself. This is the story of the shape of everything. From the moment our ancestors looked up at the night sky, they've asked, what's out there? But behind that question lurks a deeper one: what's the shape of the thing we're in? Ancient cultures imagined a dome, a vault, a firmament, a sky with edges. Today, we use telescopes, satellites, and mathematics. But the question remains surprisingly open. Let's rewind to the early 20th century. Albert Einstein changed everything. Space wasn't just a backdrop. It could bend. It could stretch. It could have geometry. There are three main shapes the universe could take. Flat, like an endless sheet of paper. Closed, like the surface of a sphere, finite but with no edge. Open, like a saddle, curved outward, infinite but still shaped. Einstein's general relativity opened the door to curved space, but it left one major problem. Which one are we living in? In 1964, a faint hiss was detected by accident. It was the afterglow of the Big Bang, called the cosmic microwave background. This light, 13.8 billion years old, carries a fingerprint of the universe's shape. And when we look at that light closely, we see something astonishing. Our universe appears to be almost perfectly flat. But there's a catch: almost. Flat to within a tiny margin of error. Could it still be curved in a way we can't perceive? Let's try to visualize. Imagine a balloon with tiny ants on its surface. As the balloon inflates, the ants see the universe expanding. They can walk in a straight line and return to where they started. This is a 2D analogy for a 3D closed universe. But here's the twist: if the universe is the surface, what is the balloon inflating into? Answer: nothing. Not space. Not another dimension. Just more universe. Because the universe isn't expanding into anything. It's creating more space itself. So now we ask the question that bends minds. What lies outside the universe? And physics replies. That question may not even be valid. You see, if the universe contains all space and time, then outside doesn't exist. There's no where or when beyond it. Trying to look outside the universe is like asking, what's north of the North Pole? But that doesn't mean we stop imagining. Enter the multiverse. Some theories suggest our universe is just one bubble in a vast cosmic foam. In this view, other universes might exist with different laws of physics. Some might be just inches away in higher dimensions. Others could be forever unreachable. And if that's true, then the outside of our universe is other universes. But so far, no evidence. Just math. Just mystery. There's a limit to what we can see: the observable universe, a sphere about 93 billion light-years across. But that's not the edge. It's just the furthest light that's had time to reach us. The actual universe could be hundreds, thousands, or even infinitely bigger. We're seeing a small patch of a possibly endless quilt. And that patch keeps getting bigger as time passes. Now, let's push further. Some physicists propose we live in a holographic universe where 3D space is encoded on a distant 2D surface. Others suggest reality itself might be a kind of computation, pixels of spacetime, run by laws like code. In these scenarios, the shape of the universe might not be a physical geometry, but an informational structure. That would make our question, what's the shape? A question about code, not space. According to string theory, the universe has more than 3 spatial dimensions. Maybe 10. Maybe 11. Most of these are curled up, too tiny to detect. But they affect how particles behave, how gravity works, and possibly how the universe itself is shaped. Our cosmos might be a 3D brain floating in a higher dimensional bulk. From that perspective, the shape of everything isn't just a sphere or a saddle. It's something we can't even picture. So what's the answer? Flat? Closed? Open? Holographic? Infinite? Maybe we'll find out. Maybe we'll never know. But the real beauty is this. In trying to answer what the universe looks like from the outside, we learn more about what's inside us. The need to ask. The desire to explore. The refusal to stop wondering. That may be the true shape of the universe. A mirror reflecting back our endless curiosity. We may never stand outside the cosmos. But within it, we are the only part that looks back and asks, what is this? What am I? Where does this all go? And that is something vast enough to shape everything.